right, the last rule we're going to talk about in this video is the power of a power rule. And so the power of a power rule says if you have a power raised to another power, then you can multiply those exponents. All right. And this is the only rule of our operational rules. You know, the product rule and the quotient rule, we both start out with two bases and we combine them to make one. Here we only have one base to start out with, but we have two exponents. So we're going from two exponents down to one single exponent. So that's the idea of this one. So let's see the example. So I have 6 to the 4th raised to the 3rd power. And so basically what I'm going to do is just multiply those exponents, right? So I'm going to keep the base 6 there, and then I'm going to multiply 4 by 3, right? So I'm just multiplying these exponents together. 4 times 3 is 12, and so that's the power property. All right, now of course we could evaluate that in our calculator, but once again, just to keep it, or just to explore why this works, let's keep it in exponential form, and let's convert this to expanded form, right? So we start out with 6 to the 4th to the 3rd. So if I were to expand that, that would be 6 to the 4th times 6 to the 4th times 6 to the 4th, right? And I could expand that all the way, right? That would be 4 6s, 4 6s, and 4 6s. So that would turn out to be, of course, 12 6s. Or you can think of the product property. If I were, since I'm on this step here, I'm multiplying all these bases, I could just add all these exponents, right? So 4 plus 4 plus 4 is 12, right? So a few different ways that you can make sense of the power rule. All right, so let's see the power rule in practice. So, and some of these will actually incorporate all of the rules that we've seen so far. So we know that the power rule says a to the mth to the nth power equals a to the m times n. So we multiply those exponents. Let me just write our other properties. A to the m times a to the n equals a to the m plus n. So we multiply bases, we add the exponents, and when we divide bases, we subtract the exponents. All right, so let's check out number 36. So here I have y squared to the 4th, right? So y squared to the quantity to the 4th power. So I'm just going to multiply those exponents. So I'm going to get y to the 2 times 4 is 8. So that's our final answer there. All right, now number 38, here we have multiplication happening, right? So remember, we do exponents before we multiply, so I'm going to do the power property first, and then I'll do the product property because of PEMDAS, right, or order of operations. So I'm going to multiply these. 2 times 6 is 12, so I'm going to get y to the 12th. All right, we did 2 times 6 there. And then I'm going to bring over the times 3y to the 5th. And so now we're going to multiply. So just like we did before, we're going to do numbers with numbers, variables with variables, like terms, right, together. So I have an invisible 1 in front of the y, so it's basically just 1 multiplied by 3. So that equals 3. And then with my y's, y to the 12th times y to the 5th is y to the 17th. Right, 12 plus 5 is 17. So I added those exponents. All right. Number 40, now we have power rule going on, but we also have some division, right? And so we're going to do power rule and quotient rule. So first I'll start with the power rule. Let me just make a little space here. So I'm going to multiply these exponents. So I'll get r to the 20th on top. On the bottom, I'll multiply these exponents. So I'll get r to the 15th. And now we're going to subtract, right? So 20 minus 15 is 5. So we get r to the 5th. That's our final answer. All right. right, 42 is similar. On top, 3 times 6 is 18, so we get w to the 18th. On bottom, 2 times 9 is 18. Now here we have w to the 18th over w to the 18th, which is w to the 0, and anything to the 0 power equals 1, right? Or remember, anything divided by itself is 1, as long as these are non-zero values. All right, number 44 kind of brings it all together. So here, I'm going to do power rule first, right? Exponents before we multiply or divide. And so I'm going to bring over everything else to 5. Oops, use blue there. So negative 5 y to the 4th. 5 times 2 is 10. On bottom, I'm going to bring over the 15 y to the 7th. And then I'll multiply 2 times 3, and that gives me 6. All right. So remember that in a fraction, we can think of the numerator, denominator, and or the denominator as if they were in grouping symbols, right? So we're going to do the numerator first, then the denominator, then we'll combine them. Okay. So in other words, we'll do the product property here before we do the quotient property. All right. So when I multiply these y's together, I'm going to bring down the negative 5. And when I multiply the y's together, I'm going to add the exponents. So I'm going to end up with a single y on top, and 4 plus 10 is 14. On the bottom, I'm going to bring down the 15, and then I'm going to multiply these y's together. So I'm going to add their exponents. 7 plus 6 is 13. So we're going from 2 y's on top to 1 y on top, right? 2 y's on the bottom to 1 y on the bottom by using our product rule this time. All right, so finally, now I can deal with these numbers here, right? I can just do what numbers do. So negative 5 over 15, we just do what we normally would if we had negative 5 over 15, which is reduce, right? So I can reduce 5 over 15 to 1 over 3. The negative stays there. So I end up with negative 1 over 3. I'll extend that fraction a little bit so I have room for my y. And with the y's, since these are like bases, I can subtract the exponents when I divide. And so I'm going to end up with y on top. And then 14 minus 13 is 1, right? But we know anything to the first power is itself. And so we'll just end up with negative 1y over 3 or negative y over 3 because 1y is just y. All right, so send questions my way, but that kind of puts all the properties in one question there, number 44. So we'll get ready to do some practice in class.